right, everybody. Well, welcome back for another exciting installment of Mrs. Bedwell's Tiny Talking Head in the corner of your screen. So anyway, a number of you have asked me for some more examples, some more practice with determining the numbers of protons, neutrons, and electrons. This is all over the test. But being able to use the periodic table or being able to use symbols to tell me the numbers of P's, N's, and E's that are found in an atom. So that's what this little one is about. If you're really comfortable with atomic mass, atomic number, being able to figure that out from isotope symbols or ion symbols, then don't even bother watching this. You're just going to be bored. So quit now while you still can. Otherwise, I'm moving forward. Okay, so basic review, just to make sure we're still on the same page. There's three basic subatomic particles. We've got protons, neutrons, and electrons. Protons are the ones that are positively charged. They give the identity of the element. You're not allowed to change the number of protons that are present. If you change the protons, you change which element you're talking about, and that's not really the chemistry that we're referring to here. The second one would be the neutrons, I guess. Picture in the lists are in different order. The picture neutrons. Neutrons are neutrally charged. They have zero charge to them. They just have mass. They're found in the nucleus, and they're related to the stability of the nucleus, and that has to do with isotopes. Again, this is mass numbers and how heavy or light a particular atom of an element is. And then the third one is about electrons. Electrons are all about chemistry. They're the negatively charged ones. They're found outside the nucleus in the cloud or in energy levels. And the gain, loss, or trading of electrons is really all what chemical reactions are about, either sharing them, getting rid of some, gaining some extra ones. That's the chemistry part. So we'll go visit those guys here in a second. And electrons are related to the concept of ions. So we've got elements, identity, we've got mass numbers and isotopes, and then we've got ions and ion charges for those three different particles. Okay, the easy one, number of protons. Please, I hope you have this, but just in case you don't, remember that the number of protons is the atomic number is the protons. Just in case, the number of protons is the atomic number. Please don't make me say that again. It's one of those things that you just need to know that from rote memory. It should be very simple that you look at that number and go, oh, that's protons, I got that. So again, keep in mind that if you know those pieces, you know the name of the element, you know the element symbol, and you know some other things about it as well. But those are the big ones. Number of protons is the atomic number. Okay, the second one, if we're talking about atoms, okay, neutral atoms. I'll talk about ions again in a second, but if we're talking about atoms, then determining the number of electrons is actually very simple. The key idea here is that atoms are neutral. They don't have an overall charge. So if I have a certain number of protons hanging around and protons are positively charged, that means I have to have the exact same number of electrons hanging around because they're negatively charged and they have to balance each other out. This is for atoms, not for ions. So I'll talk about ions here in a second. So again, the key idea here, atoms are neutral. So if in molybdenum here I've got 42 protons, that tells me that in a typical molybdenum atom, I should have 42 electrons as well. They have to be equal and opposite in terms of their charge to add up to zero. So it could be as simple as that. If we're talking about ions, however, the case gets a little bit more complex. So now ions, remember, are atoms that have a charge to them. This is because they've either gained or lost some electrons, so there's now an unequal number of protons and electrons in that particular atom. And again, these are called ions. And this has to do with a chemical type of stability that we'll refer to here in a second. Up on the screen here, there's a couple of different kind of sample element charges that you'll see. I don't know how this plus ended up down here. This plus should be up here by Mg. It should be Mg2+. So when we show ion symbols, we'll always put the charge on there with it, and it's shown as a superscript number kind of top right. And that's how we know kind of what the charge is. I'll give you some patterns in a different part of this unit about how to figure out what kinds of charges they'd have. So assuming I give you a charge, you should be able to kind of figure that out, what that number is. Oh, that's the charge. Okay, so how do we use this sort of thing? If we're trying to figure out the number of electrons that are in there, they have to add up to the charge. So this is the hard part. Protons are positive and electrons are negative. So if I have an overall charge of +1, that tells you that I don't have equal numbers of the two anymore. It's an ion, not an atom. And if it's a +1, that tells you have just one more proton than I have electrons. If it was -1, like chlorine, it tells you I have one additional electron versus I have protons that's in there. So they have to add up. And again, you can kind of think of this charge almost as like the differential between them, like Mg2+. I have 2 more protons because it's 2+. If it's nitrogen 3-, that means I have 3 more electrons than I have protons. Again, the key here, you can't change the number of protons, so you have to do a little bit of math, maybe a little bit of kind of mental wiggling to figure out what's what. So let's take a little bit closer at an example of how to kind of work these out. So we're going to decode these two. Sodium 1+. So how many protons do you have? how many electrons do you have, and how do you figure it out? Here's how I walk through this process. So the first thing I do is I sit there and go, all right, it's sodium. If it's sodium, then sodium's got atomic number 11, must have 11 protons, therefore its charge is plus 11 just due to those protons. The next part is, I know that the ion's charge is plus 1. Overall, that's kind of stepping back and looking at the big picture. I've got one more proton than I have electrons. So now I have to have 10 negative charges due to my electrons. And again, does this make sense? If I take a look at it, 11 protons and 10 electrons, does that add up to 1 plus? And the answer here is yes, obviously, because I did the example. I know I did it right. This is the case, that in a sodium atom, it would have 11 protons and 11 electrons, but in a sodium ion with a 1 plus charge, it has 11 protons, but only 10 electrons. It's gotten rid of 1. Okay, your turn. Kind of think your way through chlorine. We'll do some more examples here in a second. So again, chlorine has 17 protons to it, because it's atomic number 17. Therefore, its nuclear charge is plus 17. And now I kind of step back and look at the overall charge. Overall charge of this chlorine here is negative 1. So if the inside, the nucleus is 17 plus, but the overall total outside is negative 1, how many electrons does it have to have? That negative 1 charge tells me I have to have 1 additional electron compared to the number of protons, so therefore it must be 18. And again, I just checked my math. 17 positive charges, 18 negative charges, adds up to negative 1 overall. Your turn. So here, this little plus, again, I don't know why it's coming down here. This little plus right here should be up here. So it's Mg2 plus, and this is N3 minus. So what you should do right now is hit pause, grab a piece of scratch paper, and work this out. How many protons and how many electrons are in each of these? So hit pause, go scratch it out, and then I'm going to continue and give you the answer. So if you don't hit pause now, I'm going to give it away. A total spoiler alert right here. Major spoilers coming in 3, 2, 1. Okay, so here's the problem-solving method that I use. Number 1, start with the number of protons, the atomic number. So magnesium is atomic number 12. It's over on the left side. So that tells me I have 12 protons. The 2 plus tells me that I have to have 2 more protons than electrons. So therefore I've got 10 electrons. And you can double check. Does your math add up? 12 plus 10 minus should add up to 2 plus. And in this case it does. So let's take a look at nitrogen. And again, if you got magnesium wrong, hit pause again and go scratch that out and fix it. I'm not going to know if you actually got it wrong, so try. All right, nitrogen. Nitrogen's over on the right side. It's atomic number 7. So that tells me it's got 7 protons total in its nucleus. It's got an overall charge of 3 minus, so that tells me I have to have 3 additional electrons, 3 more negative things. So that must be, in this case, 10 electrons. Yeah, I know it's the same number top and bottom, but 10 electrons in this case. And does it add up math-wise? I've got 7 plus, and then I have 10 minus, and that should add up to our 3 minus. So that's how you kind of go through that process of kind of adding the protons and electrons to figure out the charge of an ion, or to use the charge of the ion to figure out the number of electrons. Okay, moving on. So here is our neutrons. Neutrons are all about mass number. They're all about the different isotopes, different versions of the nucleus that you can have for the same element. So here's a couple of examples of some isotopes of hydrogen, helium, and lithium, just in case you weren't sure quite what an isotope was. Again, take a look at the difference between the number of red dots and green dots. The green dots are the neutrons that are being added in there. The red dots are the protons that are in that particular diagram. So keep in mind that the protons are the ones that you cannot change. If it's change the number of protons, I'm changing which element it is. So if I'm changing the mass number, I must be increasing or decreasing the number of neutrons to figure out what that piece is. When we want to talk about specific isotopes, we have to write that out so I know which isotope number I'm talking about. 2 main ways that I can represent isotope numbers are shown in this kind of top little image. It can either be written out word-wise, like the name of the element and a dash, and then the mass number would come afterwards, or you can write it over like this one on the right, where you've got the element symbol, and then the mass number would be up at the top. Sometimes they'll include also the atomic number at the bottom, but the atomic number and the symbol are sort of redundant. If I know one, I know the other. So sometimes you see this bottom number, sometimes you don't. Down here, there's a couple other examples of carbon, so you can kind of see how the 3 different isotopes of carbon are identical or different from one another. That 6 has to be the same atomic number, same number of protons every time, but the mass number is changing across the top, and that has to be due to a change in the number of neutrons. So remember, the mass number is protons plus neutrons. It's all the things that are found in the nucleus, and those are the protons and the neutrons. So you can do a simple subtraction to figure out the number of neutrons that are present. If I've got 6 protons and 12 things in the nucleus, those other 6 things must be the neutrons. Same thing here. If I've got 6 protons and 13 things in the nucleus, that means that those must be 7 neutrons. And then the last one on the right, that 14, protons plus neutrons, right, is 14. 6 of those things are protons. That means 8 of them have to be neutrons to it. So it's a little bit of a subtraction, but it can be a trick if you're not comfortable with it. So here's your chance to practice. There's a little diagram in the center here showing 3 of these isotopes of nitrogen. You can count the circles if you really want to check it, but you should be able to figure this all out from just the numbers that's up at the top. So the strategy here, always start with the number of protons. Protons you know, because if you know the name of the element, you know the number of protons. So nitrogen 15, I know 2 things all of a sudden. I know, number 1, that it has to have 7 protons because it's nitrogen, and there have to be 15 total things in the nucleus. If 7 of those things are protons, the other 8 have to be the neutrons. So this is the time we get a piece of scratch paper, figure out the protons and neutrons that are in nitrogen 14 and nitrogen 16. Don't cheat. Actually hit pause and try it on your own, otherwise you'll never learn anything. So give it a chance to practice. Okay, coming back in 3, 2, 1. Okay, I'm going to do nitrogen 14 first. So nitrogen 14, I know that it has to have 7 protons because it's nitrogen. I also know it has 7 neutrons because in this case, 14 total particles minus 7 protons has to give you 8, nice math, Bedwell, 7 neutrons that are left over. Over on the right, nitrogen 16, let's see if I can not screw this one up, huh? So, number of neutrons, I don't know what that is. I don't know. How could it, don't panic. Start with 7 protons, right? It's nitrogen, 7 protons. 16 things are found in the nucleus, so 16 things minus 7 protons gives you the leftover number of 9 neutrons in there. Or you could have just counted the circles, but you're not going to be able to do that on the test. All right, go in this direction. A little bit harder version of it, but this is a little good way for you to practice. So I'm going to give you an isotope of phosphorus. Little image will come up here. Hit pause, and then your job now is to tell me the number of protons, number of neutrons, and the number of electrons, all 3, that are found in this isotope of phosphorus. This is the kind of stuff that you need to be able to do on the test. So here it is. It's phosphorus 32. So now is your chance to hit pause, grab a piece of scratch paper. I want to know protons, neutrons, and electrons in this isotope of phosphorus. Okay, here comes your spoilers. 3, 2, 1. All right, phosphorus. By definition, it's phosphorus. Its atomic number is 15, so it has to have 15 protons to it. Number 2, the mass number is 32 because that's given to you in the symbol. That thing that's in the top left is always the mass number. And again, the mass number is the number of protons plus neutrons. So I know that the mass number is 32, and I know that the number of protons is 15. So now it's a matter of subtraction to tell you that the number of neutrons in this particular isotope has to be 17. Okay, last one. Electrons, because this is an atom of phosphorus. How do I know it's an atom? There's no charge. If there was a charge, it would be up in this top right corner like we've seen in the other ones, and there's no charge there, so you can assume that it's an atom and it's going to be neutral. So therefore my number of electrons would equal my number of protons. So in this case, it should be 15. How'd you do? Well, there's another example, so let's give this one a try. This is pulling it all together. If you can do this, you can do any of them, and then we'll do one last example where we go the other direction. So protons, neutrons, and electrons are going to be in this bromine ion, also known as bromide. So here it comes. Again, hit pause and see if you can figure out the numbers of protons, neutrons, and electrons in bromide or bromine ion. Okay, here we go. Strategy. Start with atomic number. Always start with the atomic number. It has to be bromine, therefore its atomic number is 35. Number 2, we can start to kind of figure out, and move on, there we go, our number of neutrons. And again, the strategy with this one, here's the answer, it's 45. Where did I get that? I got that from the mass number. Combination of the mass number and the atomic number together. Since the mass number is 80, it's that number on the top left. That's got to be our protons and neutrons combined, and therefore I can do some subtraction. 80 is the total. 35 is the protons, 80 minus 35. Did I do that backwards? I did. Isn't that goofy? This number right here, that should be a 35. Bad on me. Shame, shame, shame. Okay, last one. Electrons, sorry. Electrons has to be 36. Why does it have to be 36? Well, if it had 35 protons and its charge is -1, I know something more about how this thing has to be put together. That -1 tells me I have 1 extra electron than protons. Therefore, I'd have to have 36 electrons. So there you go. We should have 35 protons 45 neutrons. Again, sorry about this typo right here. That should be a 35. My bad. And then 36 electrons. If you got that right, you're in really, really good shape. If you can do that, that's the kind of stuff I'm going to test you on. Okay, go in the other direction. Last kind of quiz element. Write the symbol for an isotope that has 16 protons, 14 neutrons, and 18 electrons. So this is going from information about the actual particles to the symbol itself. So give yourself a second and see if you can scribble this one out. See what we can do. All right, did you get it? 16 protons, 14 neutrons, 18 electrons. So strategy, use the protons, figure out what element it is. So we'll 16 protons, start there. That's got to be sulfur. The next thing is you'd use the number of neutrons to figure out the mass number. Again, neutrons and protons have to add together to be the mass number. So in this case, our mass number has to be 16 protons plus 14 neutrons is a mass number of 30. And then the last thing is you're going to use the electrons combined with protons to figure out what the charge overall is. So my protons was plus 16. My electrons is negative 18, or so 18. So my total charge means I have a 2 minus charge, 2 more electrons than protons. So did you get it? Oh, that little negative should be up here. So it should be 30s with a 2 minus charge. That little negative sign goes right there. So like I said, if you can do that, you're pretty sophisticated. All right, wrapping it up. So what should you be able to do at this point? Again, you should be able to know reflexively that atomic number and number of protons is exactly the same thing. You should be able to tell me the difference between an atom and an ion, and you should be able to tell me be able to kind of use the charge of an ion to tell me the number of electrons present. That can be kind of tricky to figure that out, that plus minus thing, to get an idea what's going on there. You should be able to do the same thing with isotopes. You should be able to tell me an atom versus an isotope. That has to do with the numbers of neutrons and how those are related. And then you should be able to use that information about mass number to be able to figure out things about the mass of the nucleus, the number of neutrons, and that comes along with kind of the numbers of protons to it. So again, the tricks here, number of neutrons has to do with mass number, number of electrons has to do with ion charge, and you have to do a little bit of subtraction to figure out those. So hope this gave you a little bit of more practice, and if you have any more questions, let me know. We'll do some more in class. Have a good day.